Hello everyone, welcome back to channel Insaan. So in today's video, we'll be implementing the LangGraph Checkpointer memory through which we will be doing auto memory management. Like before, what we are doing is we are maintaining a list, right? And we are manually appending the messages there and maintaining the history, right? So we will be skipping that. How? We will see in this LangGraph Checkpointer memory. So I have created this stage for LangGraph memory. Okay, I have already kept this llm.py. Okay, in which I have created a client to connect to the foundation model, right? That we have been repeatedly doing, right? So let's start writing code here. So first, from the LLM module, want to import get LLM functionality, right? Then from LangGraph dot graph, right? We want to import. Remember what you want to import? Messages state, right? State graph, right? All this purpose you remember start, right? Then from LangGraph dot checkpoint dot memory port memory saver, right? What is all this? I'll explain you, don't worry. Now let's create the chatbot node. For that, let's run this function and get the client to connect to the function model, right? So define chatbot. What we want LangGraph to pass the current message state, right? So let's see, this is the current state. So here we will be extracting the message state. Don't worry, we will again explain you one by one. Then we will be sending to the LLM dot invoke, right? Dot invoke message, right? So this will give me the response, right? Then we will give just the response. We will return the response, and lang graph with val do will update the state, right? We are taking the current state, updating it, and returning it, right? Return what state messages uh, on, right? So, so first we will create a graph builder, right? That is what type of state we want to manage, right? State graph. What type of state we want to manage? Is messages state. We want to manage the state of the messages. Then graph builder dot add node, right? We want to register the a chatbot node, right? Chatbot node, right? Then we want this chatbot node to be executed after the start, right? Moment the program start, this chatbot should get executed. This chatbot function should get executed, right? See, now this is the previous thing, right? All these we had done in the previous video only, right? Just we have added what here is now we are importing memory saver also. What is this? You will understand it. Okay. So after this, we will compile the graph, right? This is the structure, right? We created a graph, right? In that added node, right? We fix the sequence in which the node will get executed, right? Graph builder dot compile. Okay, what we will do right here? Just pointer equal to memory. What is this memory? So let's create a memory, right? Equal to memory saver, right? The see, don't worry, explain you everything. So let's just type the code, run it and see the output. Then we'll start understanding the code one by one. So graph builder dot compile checkpointer is equal to 3. Done. Now let's create a config variable. Okay. So through which see how we are implementing the memory, right? Okay. So there exists something like a thread ID. Okay. So every conversation there exists a ID through which we are able to recognize. See, suppose I am Ankit Dubey, okay? Let's say I am doing chatting in the chat GPT. So corresponding to me, there may be multiple chats, right? So how memory is implemented? It's like Ankit chat ID one. Okay. So user ID is Ankit and his chat ID one. Another can be another chat in which, let's say I'm talking about database. So Ankit chat ID two. Same way, right? So that's how things happen in production. Configurable. See, these are keywords. Okay, type as it is. These are predefined keywords. Configurable, thread ID. Let's say distinguishing our chat is, let's say Ankit. Okay, yes. So let's start writing the following. So user input, right? Put put what right now. The input dot lower equal to exit. Then we'll break the result, right? Otherwise, what we will do? We will do graph.invoke, right? Graph.invoke. In that, we will be returning the messages, right? What messages? This last what? Double their their input, right? This will be passed there and then we pass config. Okay, so this will give us the result. Will give us the result, and the result is a dictionary, right? We discussed in the last video what is a dictionary, right? Print AI phone result messages one some of it of dot print. Don't worry, we will understand the code. Let's first run it and see like what is happening. Properly working, right? Let's run it and check why may is too big. That's some job. Oh, okay, okay. What has happened? We have created the directly calling graph.invoke, but first what we need to do, we need to store this in a graph, right? So this is what is nice about there. I was directly written here graph variable. Okay, to graph first I need to assign its value, right? Here graph. Like, happen. Okay, it is messages, not message. It is messages, messages. Everywhere it be messages, messages. Right. What is see? Previous conversation I mentioned do way, right? In this conversation, let I am expecting it to remember it. See, your name is Dubey, right? It is able to remember, right? You saw, right? It's able to remember. And if you go in the previous conversation, the same thing we had done, we had seen that it was not able to remember, right? You want me again to go and do that, I will do that. Right? name of that? This one. Okay. Well, my two bit, right? See, in this memory was happening, right? You saw, right? I first entered, my name is Dube. Then at the next conversation, I asked, what is my name? It was able to answer, right? Let's see here what happens. Hello, Dube, it's nice to meet you. Now I will ask the next chat, the next conversation, I will ask, what is my name? See, I don't have access to personal information, right? Because the previous, what was the previous state of message? He has no idea, right? No memory implemented, right? So let's first understand this one by one. So first here, we are importing this three, right? Messages state that, as we discussed, is the schema, right? Schema which the messages are stored. What is the structure? Schema means structured. Schema structure. What is the structure? The dictionary. Okay, like this is a dictionary which messages exist. There exists list of messages, and in that there are multiple tuples, and these tuples are the message object. Getting now, what is the state graph? State graph is that what state want to manage, right? The application, right? We want to manage the state of messages of messages state, right? State of messages. So we had kept here, if you see, we created a state graph with the type what we want to keep track of, what status we want to maintain is the status of messages, right? Status of messages. Now there is start. Start is the pre-built default first step, the starting point of execution, the graph, right? Now, now from this we are importing this memory saver. Now what is this memory saver? Memory saver exists means for in memory. In memory. In memory means till the program is running, the memory is live. Okay, that is, if you exit the program, you exit memory lost. That is like our RAM is in memory, right? RAM is in memory, right? Till your laptop is running, is tracked, right? Tracked what you opened last, right? What you opened last, and all. Once closed, restart. Okay, now, right? Getting. So what we are doing here? We are running, getting client to connect to the foundation model in Bedrock, right? Now, what we are here doing? We are creating a node. Yeah, creating a node. What is this node? Node is a single unit of work, right? The work that takes the state, current state, right, as the input and returns the updated state, right, sir? So here we are taking the current messages, right? Current messages state and returning the updated Boom. Okay. Now we are creating the graph, right? Creating a graph. We are going to manage what type of application we are building. We are building a application that maintain state of messages, right? We can maintain state for multiple things, right? Now what we are doing? We have created the node. We are registering our chatbot function as the node, the graph, right? Then what we are doing? We are deciding the order. That is, after the graph start, chatbot function should be executed. Okay, accordingly we add the edges. Okay, maintaining the order. There can be multiple nodes in a graph. Okay, I have shown one here. Okay, so now what we are doing? We are creating a in-memory saver, right? In-memory saver. Here we created a memory saver. Create a memory. Okay, now see. Now what we are doing? Before we what in the last program if you see, we were just compiling the graph. We are just compiling the graph. That's it, right? Now what we are doing extra here is we are compiling the graph with checkpointers. Now why we need to do this? By default, by default, previous conversation is lost, right? After every graph invoke, right? After every graph invoke, the previous conversation is lost. Okay. So what we do? We induce checkpointers. Okay. Induce memory checkpointers through which the previous conversation we are able to track. Now, how this tracking is happening? Okay, we understood this tracking is happening. Uh, we are doing memory checkpointers to through which the previous conversation we are able to track. But how internally this checkpointer is able to track? Okay, so for that there is a config. See, there exists concept of thread ID. Okay, that is corresponding. You can say that this is the identification of individual chat. Well, chat. Okay, so when say let's say you log in to chat chat GPT. Okay, let's say you log into chat GPT. Okay, then what happens? Corresponding to your ID, let's say there will be a user ID. Okay, user ID, let's say Ankit. Okay, and there will be a thread ID, right? So that is in which chat? See, in one chat I am talking about what is database, and in another chat, let's say I am talking about what is Java programming. Okay, so there can be multiple thread IDs, right? Like chat ID 1, chat ID 2, right? So when the program runs a particular when the program runs a particular thread ID, conversation gets loaded. Okay. So what we have done here is we have created a thread. Like when we are running the program, we want thread ID corresponding to Ankit. See, I have just written a name. It can be anything. Okay. You can write it as the chat ID 1 also. Chat ID 1 also. I just write it that one. Okay, chat ID 1 also. Right. Production, I told you like how it happens, right? We are maintaining the user ID and the user ID corresponding is thread ID. Like in what chat, right? What chat? Chat ID 1, right? So this is the representative of unique conversation, right? Identification of a unique individual chat. So when we are this is right. When we are invoking, we are passing the current state along with the memory. And what memory? Good. Memory for memory for. Okay. So this is the current state. We are invoking with the current message state and load memory for the thread ID, right? As we mentioned above, chat ID, one. So this is what happens in real-time application. Okay, so suppose you log in like say like Ankit Dubey has logged into an application. You go to the like my profile, you see who is the user. Like let's say it's Ankit Dubey. Okay, so in the thread ID, I will maintain that user and I will load his conversation. Getting this is how it actually works here, right? Now what is happening here? Yeah, we are passing the current state of message and the thread ID representing the chat memory that we want to be reflected in context, right? This memory I'm talking about, right? This memory. So this thread ID, right? Chat ID one. So unique representation of the chat, like whatever chat was happening here, unique representation of the chat. Okay. So see, You know what? This graph.invoke, if you remember, we were like in all those LangChain and all LLM chatbot LangChain.py. So when we used to do, used to just return response.content, right? Right? Response.content. But here, if you see, we are doing this thing. What is this? Okay. So basically, what happens? This graph.invoke, okay, after execution, see, first of all, when the prompt comes, okay, when the prompt comes here, it goes to the chatbot node. Okay, chatbot node, it returns this response, and LangGraph updates the state. Okay, it returns the updated state. Okay, it returns the updated state. So graph.invoke returns the updated state. So what it is actually internally returning is the structure is something like this, like messages right here. Structure is something like this, messages. Okay, like first question was of user, the question was messages of tuple, right? Messages of tuple, right, like this, like this. So message of tuple user, right? Their message was hi, my name is Ankit. Okay, then AI response came. Okay, right. So says hi, happy to help you, something like that. Happy to help you. Okay, something like that. So this way it happens, right? This way. Let's say another message came for user. Let's say he asked, like, what is my name? Hmm? And the output came again of AI as your name is Angit, right? So what it is basically returning is this state. What it is returning is this state when we do graph.invoke thing. Let's suppose this was the last question. Okay, this was the last question. User input. Like this question was this. So what we are doing, we are sending this state, current state. Okay, this state. Okay, and we are sending the memory as well. Okay, and at the end, what we are getting the result. And in that result, this is the message state. This is the message state. Getting this is the message state. Okay, so this is the latest state. See, when I talk about current state, like suppose in after the two conversations, this was the response. Okay, right? Two conversation has been already done, like hi, my name is Ankit. AI told like happy to help you. You again ask what is my name. Okay, so this is now the current state. Till here is the current state, right? In this, till here is the current state. We goes to the LLM. Okay, invoke happens, and at the end this sends this as the updated state. Okay, like suppose question is, let's write here also, like question was user question, right? User question was is my name. Okay, by my name. This was the question. Okay, so first graph is invoked with current status, current status with this. Current state came as like this. Just to remove this one. Okay, with current state as this. Okay, so with this current state it went. With this current state it just went. Okay, now after that the output came. After that the output came updated state. Graph.invoke updated state came as this. Okay, as this. So this is the right dictionary. Now you see in this dictionary what I want result, I want the key messages. I am extracting the key messages, right? And if you see here -1, so in Python what happens, see there is two order. One is like this one, 0 1 2 3. This indexing happens, right? Like corresponding to this the index is 0, corresponding to this the index is 1. Okay, so 1. Okay, corresponding to 2, 2, right? 3. Okay, and when you want, like we want to only display the last content, right? This is the only the output of the current message, right? This is only the content, right? This is only the last message output, right? Okay, from this state, from this key value pairs, from this list we want to only display this, right? So what we can do, there is another reverse order also, that is -1. Write it as -2. Okay, you can refer it as -3. Okay, because otherwise what we have to do, suppose we want to display the last message, we will do again messages dot length then -1 getting. So rather than doing that, just returning last -1. So that's what I did, just representing it as a -1. Okay, and dot that's what. So still there is some problem in this. The problem in this is the memory is not persistent. Like, see, I have exited from the program, right? I have exited from the program. If I again go to that, there will be low link. There will be low link. Like if I ask what is my name, you will have no link because you are not storing in the DB, right? That is what is lacking here. What is thing? I don't have access to it. See what is happening. We are in that same file, LangGraph memory only. Okay, see this one only. But it's not able to tell. Why? Because that persistence is not there, right? We are not storing the conversation in the DB. In the upcoming videos, we will do that. If you remember one thing, prompt template, right? We are not written here prompt template, right? You see here we are directly system prompt, like how the AI model should behave, right? You see here we have just implemented that memory, right? So in the next upcoming videos, we will be integrating the memory with the prompt template. We will using the system message where we will giving the predefined instructions to the chatbot how it has to behave, right? To have some control on it. Okay, that's all for today. Keep coding, keep exploring. Ghatiya and Insaan signing off.